All right, diving into Web3.js today, finally tackling this one. Lots of you have been asking for this deep dive, and looks like we've got some promising material to work with. Got some excerpts here from Chapter-06-Primer-to-Web3-JS PDF.
Yeah, it should be a good one. Think of this as your crash course on talking to the Ethereum blockchain.
Perfect. Now, this guide kicks off by calling Web3.js a translator. What exactly are we translating here?
It's all about communication. Your browser speaks JavaScript, right? But the Ethereum blockchain, it speaks smart contracts. Web3.js bridges that gap. Lets developers use JavaScript to do all sorts of things on the blockchain. Fetch data, send transactions, even deploy your own smart contracts. Pretty powerful stuff.
So no need to learn a whole new language to work with the blockchain directly. Web3.js handles it.
Exactly, and that's where geth and Mist come in. Think of geth like the engine of the blockchain, the software running an Ethereum node.
Okay, so like a single computer on the whole network.
Right. And Mist, that's your user-friendly interface, like a browser, but for the blockchain. Makes it easier to interact with.
Interesting. Now, something caught my eye in the source here. They mentioned Web3.js uses RPC to talk to geth, but Mist uses something different.
Good catch. Yeah, Mist uses IPC, a more direct line within your computer since it's a local application.
Makes sense.
But Web3.js, it's designed for web apps hosted anywhere. So it uses RPC to send messages over the internet. Your Web3.js app could be talking to a blockchain node on a server halfway across the world.
Wow. Really highlights the whole global aspect of this technology. Now let's get our hands dirty, yeah. The source walks us through building a simple smart contract using Web3.js.
Always a good place to start. This one's a classic. A smart contract that fetches your wallet balance from the blockchain.
Basic, but I'm guessing it covers the fundamentals.
Absolutely. Connecting to a node, making a request, handling the response, it's all there. Your hello world of blockchain programming. Simple, but it opens up a world of possibilities.
Speaking of possibilities, our source then throws us into what they call the Web3.js API jungle.
Rightfully so, honestly. Web3.js is powerful, but man, it's got a lot going on. Functions, modules, it can feel overwhelming if you're just starting out.
No kidding. Like walking into a library with infinite bookshelves but no Dewey Decimal System. So what are the key landmarks in this jungle we need to watch out for?
Well, the source breaks it down nicely. Key areas like web3.eth, web3.shish, and web3.bz, think of these as our compass points.
So if I'm building a dApp that needs to talk to the Ethereum blockchain, like our wallet balance example, right, I'm hanging out in the web3.eth section.
You got it. Accounts, contracts, transactions, that's where it's all at.
Gotcha. And what about these others? Web3.esh, web3.bz. They sound kind of mysterious.
They are. Web3.ish, that's your Whisper protocol. Secure, decentralized messaging. Imagine a chat app. Totally private, no censorship. That's the kind of power we're talking about.
Whoa, that's wild. And Web3.bzz, anything to do with actual bees?
Not quite. Web3.bz is your gateway to Swarm. Decentralized storage system.
Like, what, a Dropbox, but on the blockchain?
Exactly. Instead of storing your files on some company's servers, it's distributed across the entire Ethereum network.
Wow, okay, so we've got tools for talking to the blockchain, sending secret messages, and storing files all in one library. Web3.js is starting to sound less like a jungle and more like a Swiss Army knife for developers.
I like that. And let's not forget the trusty Web3.utils. Handy functions for everything from random number generation to converting between different data formats.
Essential toolbox stuff. Building on that, the source dives into this fascinating concept, ownership contracts. Now, when I first heard that, I have to admit, I pictured like a legally binding document, but for, a digital pet or something.
Smiling, I get it. But ownership contracts in the Web3 world, they're even cooler. It's about proving you own something, digital art, music, whatever, without revealing the actual content.
Hold on. How's that even possible? It's like saying you have a secret message without anyone reading it.
That's where the magic of cryptography comes in. Specifically, something called a hash function. It takes any piece of data, big or small, and generates a unique fingerprint for it. Just like how your fingerprints are unique to you.
Okay, so say I've got this super rare digital artwork. I want to prove it's mine.
Go on.
I wouldn't upload the actual artwork to the blockchain. Instead, I'd run it through this hash function, right? And that creates this unique fingerprint. And that fingerprint is my proof of ownership. But how would anyone know that my fingerprint is connected to that specific piece of art?
You don't reveal the artwork itself. Instead, you store that hash, that fingerprint, along with your name on the blockchain. It's a public record saying you, at this specific time, had the data that made that exact hash.
Like a digital notary, but for the digital age. And since the blockchain's permanent, no one can argue with the timestamp or change the record.
Precisely. What's really cool is the source actually gives us code, both in Solidity, the language of smart contracts, and its Web3.js counterpart, shows us how to create this ownership contract.
This is blowing my mind. We've gone from translating between browsers and blockchains to digital ownership, all thanks to this Web3.js library.
And we're just getting started. This is where things get really interesting. Imagine taking this concept of ownership contracts and expanding on it.
The possibilities are pretty mind-blowing when you think about it. Ownership contracts like this could be huge, especially for digital creators.
Absolutely. Artists, musicians, anyone creating digital content. Imagine having this ironclad way to prove they own their work. It could change everything.
Totally. Now, the source actually gives us a code example for this. Could you walk us through how it actually demonstrates this ownership contract thing using Web3.js?
Sure. Let's stick with your artwork example. The code shows how, using Web3.js, you can create a function to generate the hash of that artwork. Basically, your proof of ownership.
And that function then talks to the blockchain to actually record this proof.
Exactly. You'd use Web3.js to connect to an Ethereum node and then deploy a smart contract that has the logic to store and verify these ownership hashes.
So we're going from this abstract hash function to a real, live, smart contract on the blockchain, all through Web3.js. That's pretty amazing.
It is. And the source even mentions that this is just the beginning. You can build much more complex contracts. Like, imagine having functions to transfer ownership or even verify ownership without revealing the hash itself, what they call zero-knowledge proof.
Okay, now we're getting really deep into it. It's like Web3.js is more than just a translator. It's this whole toolkit for interacting with the blockchain and unlocking all this potential.
Exactly. And that's why it's so important for building these decentralized applications, or dApps.
Speaking of dApps, our source hinted at building one that lets users register ownership of files on the blockchain using Web3.js. What would that look like in real life?
Okay, so let's say you're a photographer, right? You want to protect your work online. With Web3.js, you could create a dApp that automatically generates a hash of your photo when you upload it and records it on the blockchain. Boom. Instant proof of ownership.
No more messing around with watermarks or copyright registrations.
Exactly. And it goes beyond photos, too. Musicians, writers, filmmakers, they could all use dApps like this to protect their work. It's a whole new way to think about digital rights.
This is really exciting stuff, but let's break it down a bit. We talked about the Web3.js API with its key sections like Web3.f, Web3.esh, and Web3.bzz. How would each of these actually be used in a dApp like we're describing?
They all work together. So Web3.f is your link to the Ethereum blockchain, right? For our dApp, we'd use that to deploy the smart contract that manages ownership, like using a function within Web3.f to actually send the transaction that stores the ownership hash.
Okay, so Web3.f handles the core blockchain interactions. What about Web3.s then? Where does that fit in?
Let's say you want to add some privacy. As the creator, maybe you want to know when someone registers ownership of your work, but you don't need their name or anything.
Sounds like a job for the Whisper protocol with its secure messaging.
Right. You could use Web3.sh to build in this feature where the dApp sends you an encrypted message whenever someone new registers ownership. You get notified, but no one's privacy is compromised.
That's really clever, like a secret line of communication built right into the dApp. And what about Web3.bzz with its connection to Swarm? How does decentralized storage play into all of this?
Think about it. Storing large files directly on the blockchain can get really expensive. That's where Swarm comes in.
So instead of putting the entire digital artwork or whatever on the blockchain, you store it on Swarm.
Exactly. Keep the hash, that proof of ownership, on the blockchain because it's secure and tamper-proof, but the actual file can live on Swarm. And that's where Web3.bzz comes in handy.
So our dApp would use Web3.bzz to talk to Swarm, store the files securely, but still keep track of ownership on the blockchain.
You got it. It's all about picking the right tool for the job. And the cool thing about Web3.js is its API gives you this incredibly versatile toolkit to build some really innovative dApps.
It's amazing what we've uncovered here, from those hash functions to building a whole dApp, and it all comes back to Web3.js.
And the best part is, we're just scratching the surface. This field is young. There's so much more to discover and build.
So much potential. For our listeners who are ready to jump in and start building themselves, where would you recommend they start?
Honestly, just dive in. Start playing around with those code examples from the source. Try building a simple dApp, even if it's something small.
Like what? Got any examples?
Sure. How about a dApp that sends a time-stamped message? Nothing fancy, but it gets you working with the blockchain, and you can build from there.
Start small, get comfortable with the basics, then let the ideas flow.
Exactly. And don't be afraid to experiment with all those different parts of the Web3.js API. We talked about Web3.eth, Web3.esh, Web3.bz, but there's a whole universe of tools in there.
This deep dive has been incredible. We've really broken down Web3.js, explored its API, and even peeked into the future of dApps.
It's been a pleasure, really. And remember, the real magic happens when you start building.
Couldn't agree more. That's all the time we have for today. Thanks for joining us on this deep dive into Web3.js. Until next time, happy coding.